Okay, hello everyone. Now in this tutorial, I'm going to show how can we run a turbulent flow simulation in a L-shaped pipe or bending pipe. So now at first, I'm going to import the geometry which I have modeled in SolidWorks. Now I export the geometry and right click on 3D CAD models and select new. Then I click on 3D CAD model 1 and from import, I select CAD model and then I select my geometry. And as we can see, uh, this geometry is not uh, entirely visible or clearly visible. To make visualization perfect, I click on model visualizer here and select all, and now the model is perfectly visible. So now I back to the simulation. Now I have to create parts. To do so, I expand the 3D CAD models one, expand 3D CAD model one, expand body groups, and select body one. Then right click on body one, I select new geometry part, and then click OK. And the part is created. I can rename this body as flow pipe. Now, if I expand the flow pipe, then expand surfaces, here you can see a default surfaces is defined, which actually includes all of the surfaces of this body. In this simulation, I will assign an inlet boundary condition and an outlet boundary condition in condition into different surfaces. To do this, I I have to define those surfaces and separate from those surfaces and separate those surfaces from default surface. To do so, I right click on default and select split by patch. Now I'm willing to assign boundary, inlet boundary here and outlet boundary here. Now let's focus on this surface. I select 35. Yes. Now let's rename it as inlet. Let's create and then press create, and now let's focus on this surface. And let's select this as outlet. Let's create it, and let's close this surface, and back to the simulation. Now I have to define physics. To define physics, right click on continua and select new, and from new select physics continuum, and let's rename this continuum as turbulent flow. Now I select the models. I select three-dimensional, I select steady, I select liquid, I select segregated flow, I select constant density, I select turbulent, I select K epsilon, and then I can select boostness model, then I can select segregated fluid temperature. Actually, boostness model and segregated fluid temperature is not necessary, as we are not going to assign any thermal boundary condition. So now I can close this option, and now our model and now our physics is defined is, and the physics name is turbulent flow. Now I have to specify a material for this physics. So to specify material, I expand the models, then I expand the liquid, and here we can see water is already defined as material for turbulent flow or liquid for turbulent flow. And in this simulation, I'm going to use water, so I don't need to change the liquid here. But if we want to change the liquid here, so what we have to do is right click on H2 and select replace with, and expand the material database base and expand standards and expand liquids, and we can choose anything from this database or any liquid from this database. So in this tutorial, I'm going to use water, which is already defined. So I will cancel this option. And now I have to define the regions. Here we can see there is totally actually only one body. So there will be only one region. So right click on region, select new, and a region is created. But we have to rename the region as turbulent flow. Then I select turbulent flow, and yeah, physics content name is already defined is turbulent flow, and then I have to assign the part, which is only one part here, which is flow pipe. Now I close this window, and now I have to specify inlet and outlet boundary condition. To do this, I click on boundaries. I right click on boundaries and select new. And as we can see, a new boundary is created named boundary 1. Now I rename this as inlet. Then I select inlet and assign part surfaces by clicking here and select inlet. And from this drop down menu, I select velocity inlet as type. Now I expand physics values, and I'm not going to change anything here, static temperature, but I will change velocity magnitude to, let's say, 0.8. Then I close this option. Now I have to create a outlet boundary condition. Then again right click on boundaries, select new, then selecting boundary. At first let's rename it as outlet. Then I select outlet and assign part surfaces outlet. Then actually I don't need to change anything here except type from wall to pressure outlet. And now from physics value, I don't need to change anything here because I'm going to use 0 Pascal as outlet pressure. So I close this right now, and let's check again. Yeah, default surface is assigned with default, inlet surface is assigned with inlet, and outlet surface is assigned with outlet. Now I'm going to mesh the geometry. To mesh the geometry, I right click on operations, from new, then from mesh, I select automated mesh and select flow pipe. Then I select surface remesher, tetrahedral remesher. I can select thin mesher and prism layer mesher. Now I select automated mesh and check on per part meshing. Well, I expand the default controls from base size. I select as 4 mm. I select number of prism layers as 6. Now I run the surface measure and volume measure. Yeah, volume mesh is finished. Now if we want to see the mesh, I here Right click on new scenes and select mesh. Okay, we can visualize our mesh perfectly. And now we can run the simulation. But before that, let's suppose, well, we are going to visualize the streamline during the solution. So let's right click on scene and select scalar and move the cursor to here this color bar and select and right click on that and select here as velocity. Then I right click on derived parts. From new part I select streamline, turbulent flow, yes, regions. I can check on parts. Yeah, new streamline displayer. Yes, let's create this. Oh, seed mode is per seed and seed. Oh, yeah, I have to select a seed parts also, the regions and parts. Now, now I can create here. Okay, let's close this. Now I get back to the scalar scene 1 by expanding scenes, expanding scalar scene 1, expanding these players, expanding in this now expanding streamline, streamline stream off. I can or I can off the scalar and on the scalar scene or sorry streamline stream 1 I select a parts. Here streamline is selected and scalar field is a function of velocity. It should select this velocity. Then I close this. Okay. Now I initialize the solution and run the simulation. Here our simulation is running, and yeah, we can visualize the streamline. Actually, the this simulation will stop after 1000 iterations, but it will take so much time for this simulation. I will like to use 10 iteration, or I'll stop simulation here after 5 iteration. Let's say it is 30 iterations. After 30 iterations complete, I can stop the simulation. I will stop the simulation here. But following the same procedures, you can run the simulation with more and more iterations. Here is our mesh, scalar scene. Oh, yeah, our 30 iterations is already completed, and let's wait some times. Let's wait some time. And as you can see, the solution is not converged yet. It will take almost 300 iterations to converge, but it will take more time. So I'll stop here the iteration and solution. Following these techniques, you can run simulation for more and more iterations. And if we want to change the number of maximum iterations, so here expanding stopping criteria and maximum steps, I can select it as, let's suppose I will select it as 60 maximum steps. Then I close it. Now if we want to rerun this simulation again, what we have to do, we click on solution, then click clear solution. Yeah, the solution is cleared. And let's suppose, and if we want to visualize then the contour of outlet or velocity contour of outlet, so what we have to do again, create another scalar scene by right click on scenes, from new scene create scalar. Here we can see the scalar scene 2 and expand the displayers, expand the scalar 1 and parts. We can now I will select all parts except streamline. Yes, or I can select only outlet or inlet by disabling default here, defaults here and defaults here, and yeah, inlet and outlet. Now from scalar field I will select velocity as a function. Now I can run this. Now I run the simulation again. Here is the convergence plot, a scalar scene 1. We can see the streamline. And here it is the outlet velocity contour, and this is inlet. So inlet velocity is always fixed, and outlet velocity contour, and outlet velocity is changing here. Now let's wait for some time to complete 60 iterations. Here let's check, yeah, this velocity at outlet and streamline. Yeah, our simulation is almost finished now. Yeah, now it is showing that stopping criteria maximum steps satisfied, as I selected 60 as maximum steps. but here we can see that the solution is not converged right now, so we have to increase the maximum steps to converge the solution. Okay, then that's all for the tutorials. Following these steps, you can run simulation with thousands of iterations or maximum steps. Thank you for watching.